Today, we will introduce the relationship between oscillation characteristics and constants for the circuit evaluation process. It is necessary to select the optimal circuit constants while checking the balance of each oscillation characteristic. By changing the values of the damping resistance and load capacitance that compose the oscillation circuit, this can be accomplished. The following is a typical example of changing the damping resistance and load capacitance. We will now introduce you to the steps for basic circuit evaluation. To select the optimal circuit constants, it is necessary to check the oscillation margin, drive level, and oscillation frequency. Measurements are taken on the mounting board by changing the damping resistance value and load capacitance value. The required oscillation characteristics may vary depending on the final product, the required specifications of the IC, and the specified value of the crystal unit. Select the circuit constants while checking the balance of each oscillation characteristic. Let's see how each characteristic changes when the circuit constant is changed. First, here's an example of measuring each oscillation characteristic when the load capacitance value is changed. The oscillation frequency increases as the load capacitance value decreases. Conversely, increasing the load capacitance value will lower the frequency. Therefore, by changing the load capacitance value, the oscillation frequency can be adjusted and the desired oscillation frequency can be obtained. On the other hand, if the load capacitance is changed for frequency adjustment, the drive level and oscillation margin will also be affected. When increasing the oscillation frequency by reducing the value of the load capacitance, the oscillation margin is improved and drive levels can be reduced. However, if the load capacitance is too small, minor effects can cause frequency fluctuation and require attention. Conversely, increasing the load capacitance value allows the oscillation frequency to be lowered. However, if the value of the capacitance is too large, there is a possibility that the oscillation margin will decrease, and oscillation stability problems may occur due to the high drive level. This also requires attention. The following is an example of measuring each oscillation characteristic when the damping resistance value is changed. The damping resistor is mainly used to control the drive level. Increasing the resistance value reduces the drive level but decreases the oscillation margin. Conversely, lowering the value improves the oscillation margin but increases the drive level. By changing the damping resistance value, the oscillation margin and the drive level have opposite effects. It is necessary to select constants that provide balance to the circuit. The oscillation frequency typically varies little if the damping resistance value is changed. This is effective for adjusting the drive level and oscillation margin with little impact to the frequency. However, it is necessary to check the oscillation frequency as it may change due to the layout of components on the board and the characteristics of the IC. Finally, to summarize the relationship between circuit constants and oscillation characteristics. The oscillation frequency can be adjusted by changing the load capacitance value. To improve the oscillation margin, reduce the load capacitance value or reduce the damping resistance value. Or you can adjust both in combination. To reduce the drive level, reduce the load capacitance value or increase the damping resistance value. Or you can adjust both in combination. This section describes how to proceed with circuit evaluation basics. First, adjust the oscillation frequency by changing the load capacitance. Confirm that the oscillation margin and the drive level adhere to the required specifications of the final product, the IC, and the standard value of the crystal unit. These steps for selecting the optimal constant are the basic methods for circuit evaluations. We hope that you can refer to the evaluation methods introduced and use it for actual circuit design. If you run into a problem such as not being able to adjust an appropriate frequency, even if the load capacitance value is changed, or not being able to balance the performance with other oscillation characteristics, it may be necessary to modify the product itself. If you have any questions or concerns about IC and crystal unit characterization, please contact Murata. Thank you for watching.